Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today's video is the last video in Geometry Meet 3, so let's get right into it. So the first thing we need to talk about today is the Pythagorean Theorem. So the Pythagorean Theorem is used to find different lengths of different sides in right triangles. And a right triangle is just a triangle with a right angle. So here's how the Pythagorean Theorem works. The Pythagorean Theorem states that a squared plus b squared equals c squared. If in a right triangle, a and b are the legs of the triangle and c is the hypotenuse. So I have a right triangle here to the right as a diagram just to explain what this means. So a squared plus b squared equals c squared. That's what the theorem states, where a, b, and c are different sides of this triangle. Now specifically, a and b are the legs, which means that they're the two sides that border this 90-degree angle. So in this right triangle, this is the 90-degree angle. The two legs are the ones that border that 90-degree angle, or they're adjacent to it. Now C is what we call the hypotenuse. C represents the longest side, and it's the one directly opposite from the right angle. So A and B are the legs, or the sides adjacent to the right angle, and C is the side that's opposite the right angle. And the hypotenuse, which is C, also always happens to be the longest side in any right triangle, which is why when we say a squared plus b squared equals c squared, it makes sense that c would be the longest value. So basically, if you have two values for a and b, for example, you could use it by substituting them into the equation where a and b are to solve for c. So now I'm going to do an example question where I solve using the Pythagorean theorem for the hypotenuse. So here's a right triangle where I have two legs, 6 and 8, and I have their measures right here, and I have a question mark above the hypotenuse. And my job is to find the length of this hypotenuse. And this is a right triangle, and it will tell you it's a right triangle in questions. So I know that my legs are 6 and 8, and the Pythagorean theorem goes a squared plus b squared equals c squared. So since 6 and 8 are my legs, and they're the two sides that are adjacent to my 90-degree angle, and I'm trying to find the one opposite to my right 90-degree angle, I can just label these sides C, A, and B. And it doesn't matter which leg you label A and which leg you label B. It doesn't really matter in this equation because they're used in the exact same way. So 6 is my A, 8 is my B. So now I can substitute these into my equation where A and B were. So it should read 6 squared, because that's a squared, plus 8 squared, because that's b squared, equals c squared. All right, I'm trying to solve for c, so I'm going to simplify the left-hand side first. So 6 squared is 36, 8 squared is 64. So now if I add 36 and 64, that gives me 100. Therefore, 100 equals c squared. Now this is where it's a little bit tricky, and this is where a lot of people mess up. So I have 100 equals c squared. So c is not equal to 100. And you can probably tell that by this triangle. There's no way that this side could be 100 units long when these two are 6 and 8. A more reasonable guess would be somewhere between 9 and 12. So, but my equation says 100 equals c squared, which means c times c equals 100. So the way that I find the value of c is you honestly just have to find the square root of both sides. Because if you think about it, the square root of 100, which is what number multiplied by itself equals 100, will be equal to the square root of c squared. Since 100 equals c squared, the square root of 100 equals the square root of c squared. And since c squared is just c times c, and square root means what number multiplied by itself gets you to this, well, c multiplied by itself gets you c squared. So the square root of c squared is just c, because square root and squared cancel out. So therefore, the square root of 100 should equal c. And you have to use square root here in order to find the value of the side. So I have the square root of 100 equals c. And so now if I just know my square roots, then the square root of 100 is 10. So therefore, 10 equals c. And the length of my hypotenuse is 10 units long. And then one other thing about the Pythagorean theorem is it can also be reformatted to find the length of a side. Right now it's formatted so it's a squared plus b squared equals c squared, where c squared is the value that you're solving for. It can be reformatted to say c squared, or the hypotenuse squared, minus a squared, or the value of one of the legs squared, will equal b squared, or the value of the other leg squared. And using this formula, which is the same one as this, just edited slightly, you can solve for the value of a leg. So next we need to talk about area. So area is defined as the amount of space inside a shape. And since different shapes have different area formulas, unfortunately, you are going to have to memorize a bunch of different formulas in order to find area. But by the way I'm going to introduce them to you, I'm going to try to make it a little bit easier to memorize. So the first and most basic area formula is the area of a rectangle. So the area of a rectangle is just BH, where B is your base, or the bottom length, and H is your height, which is pretty easy to see. So it's just B times H. So in example, if I had my height as 2 units and I had my base as 4 units, then the area would be 2 times 4, which is base times height, and that gets me 8 square units. Now the reason that this works is because if you think about what this means when it's 2 units tall and 4 units long, or I have a 4-unit base, I could divide the rectangle up like this. Now it's divided into 2 units of height, and 1, 2, 3, 4 units long. And if I think about this, these dotted lines dividing the sides into their actual lengths creates an array. So I have 1, 2, 3, 4, 5, 6, 7, 8 square units on the inside, which is why you multiply the base and the height to find the area. All right, so next is the area of a triangle, which is actually really similar to the area of a rectangle, except it's 1/2 BH, where you still multiply the base and the height, but you also have to multiply it by 1/2. And it's the exact same thing where the base is just the length of the bottom side, and the height, and this is very easy to mess up, is the height from the bottom most to the topmost point in this triangle. Now, some people will say, oh, well, the height is this. And that's actually incorrect because this is what we call the slant height. Sometimes in IMLEM questions, they'll ask you to find the area of a triangle, and they'll give you this length here. This is not the height. This is what we call the slant height. The height is the vertical distance from the top to the bottom. This isn't a vertical line, which is why we can't use this as height. So in a triangle, say I had my base as 4 and my height was 2, similar to this one, then my area would be 4 square units. And the reason this works is because if you think about what this triangle means or how you break up this triangle, say I take my triangle and from here to here, I draw a rectangle around it. What you'll notice is since I perfectly drew a rectangle extending from here all the way to the top, so with the same height and then the same base, so with a rectangle with the same height and same base has exactly twice the area. And that's why I drew this dotted line in the middle. So you'll notice that this triangle here and this triangle here are the same area, and then this one here and this one here are the same area, which is why that a triangle with exactly the same height and the same base as a rectangle will have half the area of that rectangle. All right, and then the next area formula we're going to talk about is the area of a square. So the area of a square is pretty simple. It's just s squared, where s is the length of a side. Now the reason this works is because if you think about it, a square is just a type of rectangle, right? A rectangle is just a shape with 4 sides and 4 right angles. A square is a shape with 4 sides and 4 right angles, but all the sides are equal. So if all the sides are equal and your area of a rectangle is base times height, well, the base and the height will have the exact same length because those are just the side lengths. So therefore, if I multiply the side by the side, which is the exact same as base times height in a square, then that should give me the area of the square, which gives me side squared. And we have 2 more area formulas to talk about. So the next one, and probably the most complicated one, is the area of a trapezoid. But unfortunately, I'm guessing this is the one that also shows up either the most or second most in IMLEM questions. So the area of a trapezoid is 1/2 a plus b times h, where a and b are the bases and h is the height. So a trapezoid's kind of special in that the top base is not equal to the bottom base. So in a rectangle, the top base is always going to be equal to the bottom base. So if this is b, then this is also b. They have the exact same length. In a trapezoid, though, you don't have 4 right angles, so this isn't the exact same case, where a and b, which are your 2 bases, the one on the top and the one on the bottom, will have different lengths, which is why we have to have them both in this area formula. So if you find the lengths of your 2 bases, so we'll use 3 and 5 as an example, and you have your height, which is, again, the distance from the top to the bottom, or the bottom to the top, vertically, not the slant height, and this is the slant height in a trapezoid. It actually has 2 slant heights on either side. So if you find the lengths of your bases, which are 3 and 5 in this example, and your height, which I'm also going to call, I'll call this 2, then you can use this to find the area of your trapezoid. You add a and b, which will be 3 plus 5, and that gives me 8, and then you multiply that by 1/2, and you multiply that by the height. So 1/2 times 3 plus 5, which is 8, times 2 gives me 8. So this trapezoid would have an area of 8 square units. Now to explain why this area formula works. So this is probably the most complicated one to explain, but just stick with me here. So if I were to divide this trapezoid up into 2 triangles, right? So I can do that by drawing a line across like this. Now I've divided this trapezoid up into 2 triangles, which I'm going to call triangle A and triangle B. And I'm actually going to do these in capital letters so we don't confuse these triangle names with base A and base B. So now I have triangle A and triangle B that make up my trapezoid. Now if I can find the area of each of these individual triangles, right? Say I were to take triangle B. So this is triangle B here. Well, its base goes from here to here. It's the length of base B of the trapezoid because it's the bottom length. And the height, which is the height from the bottom to the top, is the height of this triangle. So therefore, the area of triangle B will be 1/2 times B times H. Now if I'm going to triangle A, which is the other part of my trapezoid, or the other triangle that makes up my trapezoid is triangle B. If I go to triangle A, I'm going to use this length as the base. And I can use this because it's a horizontal distance, right? It's from one side to the other side. It doesn't really matter if it doesn't stretch all the way across like this. That's why you have your height as a specific measured value from the bottom to the top. So my height of triangle A, and I'm actually going to draw those dotted lines back in, will be this height right here. And if you look over where I have the exact same dotted lines, that height is actually equal to h. The height of my triangle A is equal to h because it's from the top to the bottom, which just happens to be the same as from the top of this trapezoid to the bottom of this trapezoid. So since A, the base A is my base, and h is my height, then therefore the area of triangle A is 1/2 AH. Okay, so I have the area of my 2 triangles, 1/2 times BH and 1/2 times AH. And these 2 triangles together make up my big trapezoid. So since I have the area of these 2 triangles, and since you can do this with any trapezoid, split it up into 2 triangles with the 2 different bases, then therefore, since I'm multiplying both of them by 1/2, if I combine these formulas, it'll be 1/2 times A plus B, or your 2 bases added together, times the height, or the area of the 2 triangles bases added together, and then you find the area of a triangle. So that's why this formula works, because you're finding the area of 2 triangles in one formula by adding your 2 bases, A and B. All right, and then the last area formula we need to know is the area of a parallelogram. So the area of a parallelogram is actually just BH. It's the exact same as the area of a rectangle. Except make sure, again, I'm going to say this a lot of times because I frequently mess this up, a lot of my friends frequently mess this up. This is the slant height. This is the height. Make sure to use the height, which is the vertical distance from the bottom to the top. This is not a vertical line, this one is, which makes this the height. All right, so BH is my area, and the reason this works is because see where it drew the dotted line for H? If I actually created a solid line and broke this parallelogram up into this triangle in this shape right here, which happens to be a trapezoid, if I were to actually move this triangle here over to this side, like this, you'll notice it actually creates a rectangle. If I move this triangle over to here, it creates a rectangle. And this rectangle is going to have the exact same base because the base of a parallelogram on the top and bottom are the exact same. So it's going to have the exact same base and the exact same height, which is why you can use base times height for a parallelogram. Because if you just cut off one part and move to the other side, it turns into a rectangle with the exact same base and the exact same height. All right, so now I have a review question on area and the Pythagorean theorem. If you'd like to try it, I'll give you a few seconds to pause the video and then I'll explain the answer. So the correct answer to this question was 60 units squared. So here it says, what is the area of the trapezoid below? With this being the trapezoid below. So here's my trapezoid. So the first thing I'm going to do is write out the formula to find the area of a trapezoid, which is A equals 1/2 times A plus B, where A is my top base and B is my bottom base, times H, where H is my height. So 1/2 times top base plus bottom base times height. Okay, so in order to find this area, all I need to do is plug in the values of my top base, my bottom base, and my height. So my A, which is 12, I can plug in. So A equals 1/2 times 12, and then plus B. So B, well, I actually don't have a value of B here. It doesn't tell me what the length of my bottom base is. So for now, I'm just going to leave that in the equation as B. And then times my height. And my height, which is not 5, because this is not the vertical distance, is 4, because 4 is the vertical distance from the top to the bottom. So times 4. So far I have A equals 1/2 times 12 plus B times 4. So now in order to find my area, I really need to find B, but it doesn't tell me B in the diagram. So there needs to be some way in order to find the length of the bottom base. And the way you have to do that is by using the Pythagorean theorem. So if I look here, it does give me some extra values. It gives me the slant heights. And I said sometimes they'll throw in the slant heights to trick you, but in this question, you actually need these values. And the reason why is because you can use it to find the value of the bottom base. If I think about what the bottom base is, and I draw another dotted line here, you'll notice that the length from here, this dotted line to this dotted line, is the exact length of the top base. The length from this dotted line to this dotted line is 12 units long, because this creates a rectangle, and in a rectangle, the top and bottom base always have the same length. So from here to here is 12 units long. And the reason that helps is because now if I can find the lengths of each of these individual sections, then I can add them together to find the length of the entire bottom base. Now, the bottom sections of these two are the bottom sections of triangles, or the bases of triangles. But more specifically, they're also the legs of right triangles. Because my height, since it's a vertical distance, and since my base is horizontal, when they meet, they're perpendicular, which makes this angle here a right angle. So now I have a right triangle that I can use the Pythagorean theorem to find the length of each of these legs. So if I'm trying to find the length of a leg with my Pythagorean theorem, then I can write it as c squared, which is my hypotenuse squared, minus a squared, which is one of my legs squared, equals b squared, which gets me the value of my other leg squared. So I know my hypotenuse, which is 5, or the slant height of this trapezoid is the hypotenuse of this right triangle. And then one of my legs is 4, because that's the height of this triangle. So if I do 5 squared minus 4 squared, that's going to get me b squared, where b squared is the leg that I'm missing, or this length right here, which is which is b. And so I can use this to add to 12 and find the length of this entire bottom base. So 5 squared is 25, 4 squared is 16, and that's going to equal b squared. And then 25 minus 16 is 9, so 9 equals b squared. So now what I have to do is find the square root of both of these sides, So the square root of 9 equals the square root of b squared. And the reason this helps is because when I find the square root of a number squared, it just cancels out to that number. So the square root of 9 equals b. Because b squared is just b times b, and the square root means what number times itself equals whatever number you're trying to find the square root of. So the square root of b squared is b. So the square root of 9 equals b, and since the square root of 9 is 3, since 3 times 3 equals 9, then the length of my bottom leg here is 3. So 3 units long. All right, so now I have this leg, or this section of the base. I have my 12 here, which I always had. Now I have to find this section. Well, you could go through the calculations again, but you'll notice that it has actually the exact same side lengths. The slant height is still 5. This bottom length is 4. So therefore, the length of this bottom section has to be 3, because we already did the math for this. 5 squared is 25, 4 squared is 16, 25 minus 16 equals 9, and the square root of 9 is 3. So 3 is the length of my bottom leg here. And this is actually what we call a Pythagorean triplet. When 3 numbers, say 3, 4, 5, follow the Pythagorean theorem. So if you have some Pythagorean triplets memorized, you could have just seen, oh, well, my hypotenuse is 5, one of my legs is 4, so therefore this is 3. And you wouldn't even have to do the math. But anyway, if you do the math and you get 3 for both of these, and you have 12 here, then you can find the length of this bottom base. It's 3 plus 12 plus 3, which is a total of 18. All right, so now if I put this in my area formula, then I have area equals 1/2 times 12 plus 18 times 4. And then if I do my 12 plus 18 first, and I'm actually going to erase some of the stuff so I have some more room. So area equals 1/2 times 30, because 12 plus 18 is 30, times 4. And then if I evaluate this, it gets me area equals 1/2 times 30, which is 15, times 4. And 15 times 4 is 60. So my area is 60 units squared. And if this were an actual IMLEM competition, if you just wrote 60 and you didn't write units squared, you'd be fine. They still count it as a correct answer. In IMLEM competitions, you don't have to label the answer. In fact, if you label it incorrectly, say you labeled this with centimeters squared, well, never said anything about centimeters, then they would count it as wrong. So if you're at an IMLEM competition, I would suggest writing the number out and not labeling it at all. And finally, we need to talk about diagonals. So a diagonal is defined as a line segment that connects 2 non-adjacent vertices of a polygon. So down here, I have an example of a pentagon, which has 5 sides and 5 diagonals. So the diagonals are labeled inside the polygon. They're the different dotted lines that are connecting the vertices. And if you don't know what a vertex is, it's just the different points where the different sides intersect. So this polygon has 5 vertices. And as a fun fact, every polygon will always have as many sides as it does vertices. So an 100-sided shape would have 100 vertices. So a line segment that connects 2 non-adjacent vertices is a diagonal. So non-adjacent, because it says it has to connect 2 non-adjacent vertices. So non-adjacent means that they're not right next to each other. So say I took this vertex and this vertex as an example. Well, these 2 vertices are right next to each other because there's no vertex in between them. But if I took this one and this one, these 2 are non-adjacent because there's a vertex, which is this vertex, in between them. So a diagonal then connects 2 non-adjacent vertices, which is why all of the diagonals you see here are connecting non-adjacent vertices. Because if they were to connect adjacent vertices, like I connect this one and this one, then it would just create a side. All right, so the diagonal connects 2 non-adjacent vertices. In this 5-sided shape, which is a pentagon, just happens to have 5 diagonals in it. But there's not always as many diagonals as there is sides in a polygon. This one just happened to be 5 sides and 5 diagonals. Some will have more diagonals than sides, and some will have less diagonals than sides, though. So now I'm going to teach you a formula to find how many diagonals any shape has. And the formula goes like this. 1/2 n times n minus 3 will give you the number of diagonals in a shape, where n is the amount of sides or amount of vertices in a shape. Because remember, a shape will always have as many vertices as it has sides. So n is the amount of sides or amount of vertices. So therefore, you take 1/2 times the amount of sides times the amount of sides minus 3, and that gives you the number of diagonals. So now if I were to use this 6-sided shape as an example, which is a hexagon, then I go 1/2 times 6, because 6 is n, times 6 minus 3, and that gives you the number of diagonals. So 1/2 times 6 is 3, 6 minus 3 is 3, and then 3 times 3 is 9. So this hexagon has 9 diagonals total. So now I'm going to attempt to explain why this formula works. And we can break it down into 3 main sections: n minus 3, n, and 1/2, because they're all being multiplied by each other. So first I'm going to start with the n minus 3. So where does n minus 3 come from? So in any shape, you're always going to have as many sides as you have vertices. So therefore, n represents the amount of vertices you have in a shape. Now, if we think about how many diagonals can be created from each vertice, so I'm going to use this vertice first. Well, it can be, so in this 6-sided shape, we can create 1, 2, 3 diagonals from this vertice, right? There are 6 vertices total, and we can create 3 diagonals from this vertice. And the reason why is because out of the 6 vertices, 3 of them are non-adjacent. 1, 2, 3. 2 of them are adjacent, which means you can't create a diagonal with these 2, and 1 of them is itself. And this applies to every single vertice in a polygon. They're always going to be able to create as many diagonals as there are vertices minus 3, or minus the 2 that are adjacent and the 1 that is itself. So therefore, n minus 3 represents how many diagonals each vertice can create. All right, so next to deal with this n. So this n here is the next section that I need to explain. So this n represents how many vertices there are. So if I take the amount of diagonals that each vertice can create, which is n minus 3, and multiply it by the amount of vertices, then I get how many total diagonals there are in the shape. Except this is actually incorrect, which is where the 1/2 comes into play. So the reason that you need the 1/2 is because even though you're representing how many diagonals each vertice can create multiplied by the total amount of vertices, you're not accounting for diagonals that were already created. So let me show you what I mean. So I'm going to take this vertice as an example and create 3 diagonals that I showed you. So 1, 2, 3. Now if I move on to the next vertice, which is this one, and I create my diagonals, I get 1, 2, 3. All right, so I still don't have a problem. But when I move on to this vertice and I create my diagonals, I get 1, 2, and then I realize that this diagonal from this vertice to this vertice has already been created. And if I keep going like this, I'm going to notice this one already had 2 diagonals created. I can only create 1 more diagonal to here. And then as I go along, this vertice and this vertice have already had all of their diagonals created. And if you think about what this means, it means that for every vertice that you have that creates a diagonal, say I had vertice A and vertice B, and in between them I created a diagonal. Well, you can create a diagonal from A to B, but you can also create a diagonal from B to A. So for every diagonal that you create with this formula, you're actually creating a double that goes back the other way, which is why when you multiply it by 1/2, you count for that second diagonal you created with this formula, so you only have 1. And that's why you have to do 1/2 times n minus 3. All right, and finally, I have a review question about diagonals. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 19. So the question says, how many more diagonals are there in a dodecagon than a decagon? All right, so our diagonal formula is 1/2 times n minus 3. And it says, how many more diagonals are there in a dodecagon than decagon? So it's saying how many more diagonals are there in one shape than another. So therefore, I'm going to have to use this formula twice for 2 different shapes and then subtract the amount of diagonals there are in either shape. So first I need to find how many diagonals there are in a dodecagon. And if you don't know, a dodecagon has 12 sides. you're actually going to have to memorize how many sides lots of shape all the way up to dodecagon have just by the name. So decagon has 10 sides, dodecagon has 12 sides, so we're going to be using 12 and 10 for this question. So first, I need to find how many diagonals there are in a dodecagon. So therefore, I substitute in 12 for n, because there are 12 vertices and 12 sides in a dodecagon. So 1/2 times 12 times 12 minus 3, where 12 is in the place of n, gets me 1/2 times 12 times 9, because 12 minus 3 is 9. And then 1/2 times 12 is 6. And then 6 times 9 is 54. So there are 54 diagonals in a dodecagon, or 12-sided shape. All right, now I need to find how many diagonals there are in a decagon. So I write out my formula again, which is 1/2 times n minus 3, and substitute in 10 for n. So 1/2 times 10 minus 3 gets me 1/2 times 10 times 7. So I'll write that out, 1/2 times 10 times 7, because 10 minus 3 is 7. And then 1/2 times 10 is 5. And then 5 times 7 gets me 35. And from here on out, it's just simple subtraction, because it says how many more diagonals are there in a dodecagon. Therefore, I need to find the difference between these two. So if I subtract 35 from 54, then that gives me 19. There are 19 more diagonals in a dodecagon than a decagon. All right, now to review what we've learned this lesson. So we started by learning about the Pythagorean Theorem, which is a theorem to find the different lengths of different sides in a right triangle. And this only works in a right triangle, where a squared plus b squared equals c squared when a and b are your legs, or the sides adjacent to the right angle, and c is your hypotenuse, which is also the longest side in any right triangle. So then we did an example where we found that a triangle with legs 6 and 8 will have a hypotenuse of 10 units long. And then we also learned that the Pythagorean theorem can be reformatted to say c squared minus a squared equals b squared. The hypotenuse squared minus one leg squared equals another leg squared. So you can use it to find the length of a leg as well, and not just the hypotenuse. Next, we talked about area. So in order to find the area of different shapes, you have to memorize a lot of different formulas, but I did my best to explain it in a way that helps you memorize it. So we started with the area of a rectangle, which is b times h, where b is the base and h is the height. Then next we moved on to the area of a triangle, whereas 1/2 bh, where b is the base and h is the height. But h, you have to make sure you use the vertical height and not the slant height, where the vertical height is a vertical line that can be drawn from the top to the absolute bottom of this triangle. And the reason it's 1/2 bh is because it's going to have exactly half the area of a rectangle with the exact same base and height. And then we talked about the area of a square, which is s squared, because in a square, it's basically just a rectangle where all of the sides are equal. So therefore, the base and the height are equal. So s squared equals bh. Then we continued with area and talked about how to find the area of a trapezoid, which is 1/2 times a plus b times h. And the reason that this works is because if you divide it up into two triangles, they're going to have bases a and b, and they're also going to have height h. So therefore, 1/2 a h and 1/2 bh will be the area of your triangles that make up the entire trapezoid. So 1/2 a plus b times h will be the area of the entire thing. And then finally, we talked about the area of a parallelogram. And the reason that the area of a parallelogram is b times h is because if you cut off this section of the parallelogram and move it over here, it just becomes a rectangle with the exact same base and exact same height. And then we did a review question to find the area of a trapezoid, where we had to use the Pythagorean theorem and the trapezoid area formula to find the area as 60 units squared. And then finally, after that, we talked about diagonals, which are line segments that connect two non-adjacent vertices of a polygon. We learned the formula to find how many diagonals there are in a shape, which is 1/2 times n minus 3, where n is the amount of sides or amount of vertices in a shape. And then we used a hexagon as an example, found that it has 9 diagonals, and then I explained why this formula works, because we're multiplying how many diagonals each vertice can create, multiplied by the amount of vertices, multiplied by 1/2, to account for diagonals that were already created. And then we did a review question about diagonals where we found that there are 19 more diagonals in a dodecagon than a decagon. All right, so that's all I have for today's lesson, and that's actually it for the geometry section for Meet 3. I hope this video was helpful, and I'll see you next time.